Okay, this lesson is about parallel lines and the kinds of angles that they form. But before we jump into parallel lines, we're just going to talk about any two lines that are in the same plane that are intersected by a transversal. So your transversal is your line that intersects the other two lines that are in the same plane. You have a place in your notes to put that. And here's your definition. A transversal is a line that intersects two lines in the same plane. When two lines are intersected by a transversal, a lot of different types of angles are formed, and we're going to talk about three types. The first one we're going to talk about is corresponding angles. Corresponding angles are going to be two angles in corresponding positions relative to the two lines and the transversal. So first jot this down, and then I'll give you a picture of what those kinds of lines look like. Corresponding angles are angles that are in the same relative position. What that means is this angle 1 is in the top left quadrant of that set of angles. It's corresponding with angle 5 because they're both in the top for their set of angles. And then we have angle 2 corresponds to angle 6. They're both in the top right for their set. 3 corresponds with 7. They're both in the bottom right. And then we have 4 and 8, both in the bottom left. Those are our corresponding angles. The next type of angles that are on your sheet are co-interior angles. Co-interior angles are two interior angles on the same side of the transversal. Co means they're going to be together, so that this time they're on the same side of the transversal, but they both need to be on the interior. So the picture that goes with that would be 4 and 5 are co-interior, because here's your transversal. They're on the same side of the transversal. And we can highlight all of this. This is our interior, because that's the part that falls between the two lines. So the only interior angles we have are 3 and 4 and 5 and 6. So 4 and 5 are co-interior, and 3 and 6 are going to be co-interior. Then our last type of angles we're going to have here is alternate interior, and they're going to be two interior angles on opposite sides of the transversal. They not only need to be on opposite sides as far as right and left go, they also need to be on opposite sides kind of top and bottom. I'll show you what that is. So the picture that goes with that one, oops, not that. Let's move these two. More crazy movement. Now 4 and 6 are going to be our, and 3 and 5 are going to be alternate interior. Right and left side, top and bottom, but still on the interior of the two main lines. Okay. We've talked about co-interior, we've talked about corresponding, we've talked about alternate interior angles. Those angles don't have any kind of relationship if you just have two random lines cut by a transversal. However, what's different about these two lines?
Parallel.
They're parallel. So when parallel lines are cut by a transversal, then we do have some special relationships. Let's first talk about angle 1 and angle 2. Now, which type of angles are those?
Alternate interior.
Those are my alternate interior because they're on alternate sides of the transversal and they're on the interior. I want to measure them. I'm going to bring my protractor out here and lay it on there. Now, I just want to give you a reminder on measuring with a protractor. I always have people say, oh, I just used the wrong number. Okay. Are you going to start measuring with 0 or with a 180? 0. Do you ever pick up a ruler and start measuring from the 12?
No.
No, you always measure from the 0. So do the same thing when you pick up a protractor. Measure from the 0. So angle 2 is going to be 10, 20, 30, 40, 50, 60, 70 degrees. All right, let's turn it around and measure angle 1. Start measuring with the 0 again. 10, 20, 30, 40, 50, 60, 70. So angle 1 and angle 2 are both 70 degrees. When the lines are parallel, those angles are going to have the same measure. So this is a theorem I need you to write down. And I'm going to first give you the full statement, and then I'm going to give you an abbreviation. So let me give you the full statement first. If two parallel lines are cut by a transversal, then alternate interior angles are equal in measure. Write that down. If two parallel lines are cut by a transversal, then alternate interior angles are equal in measure. Once you have that written down, you can write down this abbreviation. When you use this theorem in a proof, you're either going to write out the whole statement or you can write out this abbreviation. But this theorem doesn't have a name, so you need one or the other. I would draw a picture to go with this in your notes and just label one set of alternate interior angles. So that was alternate interior. Now let's talk about corresponding angles. I'm going to pick this set of corresponding angles right here. Okay? What did we say about, let's pull this one back up. What did we say about angles 1 and 3? What do we know about that? They're equal in measure because they're what kind of angles?
Alternate
Interior. What are 2 and 3? What type of angles are those?
Linear.
Vertical.
Oh,
They're vertical angles. What do we know about vertical angles?
they're equal in
They're
measure.
equal. So if 1 is equal to 3 and 2 is equal to 3, what do I know about 1 and 2?
They're equal.
They're equal. I don't even need to measure to show you. But corresponding angles are also equal in measure. So that's your next theorem. If parallel lines, write this down, if parallel lines are cut by a transversal, then corresponding angles are equal in measure. Cut by a transversal, then corresponding angles are equal in measure. Your abbreviation for this one is very similar. Right here you have parallel lines. Remember the arrow means implies. So parallel lines implies corresponding angles are equal in measure. So we've talked about alternate interior and corresponding. What's left?
Co-interior.
Co-interior. So 1 and 2 are co-interior. What do I know about 2 and 3?
They're equal in measure.
They're equal to each other. What do I know about 1 and 3? What type of angles are those? They're supplementary because they're what kind of a pair?
Linear.
They're a linear pair. So if 1 and 3 are supplementary and 2 is the same as 3, what do I know about 1 and 2?
They're supplementary.
They're supplementary, and we're going to do a proof of that in your homework. But 1 and 2 are supplementary. So that's your next theorem is if parallel lines are cut by a transversal, then co-interior angles are supplementary. Okay, here's the last abbreviation that you need. Parallel lines implies co-interior angles are supplementary. Be sure you're identifying at least one set for each one of those so that you have a picture to go along with it in your notes. Okay, I want to pull in some shapes because when we're just looking at the parallel lines and the transversal, it can be pretty easy to identify once you've practiced. But when we pull in a shape, all of a sudden we have more lines, and so we need to be really careful. This first shape that we have is a parallelogram. And what's the definition for a parallelogram? What do we know it has? 2 sets of parallel sides. So let's start with this one and this being our parallel side. That would make this line our what? Our transversal. What kind of angles then are this one and this one? Should not put those in. They're co-interior. And what do you know about co-interior angles? When you have parallel lines. They're supplementary. So this is another theorem for you to write down. It's written like a conditional. If a quadrilateral is a parallelogram, then consecutive angles are supplementary. If a quadrilateral is a parallelogram, then consecutive angles are supplementary. Okay, now let's erase this and look at 2 different lines. What do we know about these 2 lines? They're parallel, which makes this a transversal. It's fine that it's facing a different direction. That's not a problem. So what do we know about Those two angles, what type of angles are they?
They're co-interior angles.
They're co-interior. They're on the same side of that transversal, and they're on the interior of these two. You know, co-interior angles are supplementary. So 1 and 2 are supplementary, but what did you just tell me about 1 and 3?
They are also supplementary.
They're also supplementary. What do we know about 2 angles that are supplementary to the same angle?
They're equal.
They're equal. So that's a separate theorem, but here we have another one for you to write down. If a quadrilateral is a parallelogram, then opposite angles are equal in measure. So those 2 angles are going to be equal, and then 1 and 4 are also going to be equal. Okay, here we have a triangle, and I drew this line so that it was parallel to this line. Remember, that's what the arrows mean. Which makes this line a what? Transversal. So what kind of angles are 1 and 2? Corresponding angles. We also have a transversal over here. What kind of angles are 3 and 4? Corresponding. What are 4 and 5? Co-interior. What are 3 and 5?
Supplementary. No, linear.
They're a linear pair. They're a linear pair. Now, something good to note. See how these 2 angles, 1 and 2, are both created using the red lines and that blue line over there? Okay. I want you to notice 1 and 4 have no connection. 4 is created using this line and this line. Let me. 4 is created using this line and this line. And 3 was created using this line and this line. If they don't share lines, they can't be any of our special angles. They can't be alternate interior, co-interior. You want to look for things like that because we want to try and find alternate interior and co-interior, but you can't always find them. So be careful when you're looking at a shape. Okay, now we're going to use all the information we have to do our first proof today. Lines M and N are parallel, and transversal T intersects lines M and N. When you're doing one of these proofs, you always want to have a picture, and you want to be sure your picture is labeled. If you don't already have a picture, draw it, and then be sure it has all of the correct labeling. So we have lines M and N are our parallel lines. I'm going to label them M and N. And our transversal is T. I'm going to label my transversal T. And we want to prove that angle 1 is congruent to angle 2. So, what kind of angles are 1 and 2? Alternate interior. And we already know that if the lines are parallel, which was given, then alternate interior angles are equal in measure. When you see something like that and you're like, oh, we have a theorem that says that. We do. That's what we're trying to prove is that theorem. So remember when I talked about class, you cannot use a theorem to prove itself. That's like when you're trying to be your own alibi. I didn't do it because I was with myself at home. I know I was there. That's not going to work in court. And so the same thing is true here. We have to use all of our other theorems to prove this one is true. So when we're trying to prove 2 angles are equal to each other, it's always good to try and see if you can find another angle that has a relationship with both of those. So I went ahead and gave you one, so you didn't have to think too much about it. I gave you angle 3. So the first thing I want you to think about, and don't say anything out loud, but I want you to think about what kind of angles 1 and 3 are, and do they have a relationship? And then I want you to think about 2 and 3, and what kind of a relationship do they have?
I don't have it, I swear.
Stop getting violent.
I found it. Brandis.
Vertical.
Which are vertical?
2 and 3 are vertical.
2 and 3 are vertical angles. And what do we know about vertical angles?
They're measure.
They are equal in measure. The vertical angle theorem tells us that. Emma, what about 1 and 3?
They're corresponding.
And what do we know about corresponding angles?
They're equal.
They're equal because the lines are parallel. So if 1 is equal to 3 and 2 is equal to 3, what do we know about 1 and 2? They're equal. That's our proof. So we kind of thought through it first, and now we're going to write down logically how that plays out. So let's start with our given. We were given that M is parallel to N. There's a nice little shorthand for you. M is parallel to N, but you're welcome to write that one out in words. And then we have transversal T. You're welcome to write there, cut by a transversal or something, but this way we know we have the transversal. And that all information is known because it was given to us in the given statement. Then we're going to tie those angles together. It doesn't matter if we talk about the vertical angles first or the corresponding angles first. Brenda said the vertical angles first, so I'm going to start with 2 and 3. The measure of angle 2 is equal to measure of angle 3. And what tells us that? What theorem or definition? The vertical angle theorem. If you forget the name of it, you can always write it out. Vertical angles are equal in measure.
Theorem?
Theorem.
Maybe there was some odd letter there.
Yeah, don't actually look for it.
I'm gonna cry because Kathy
Yeah,
told
you
me.
cry.
Okay, the vertical angle theorem. Now we've got, we want to tie 1 and 3 together. What do we know about angles 1 and 3?
Corresponding.
So they were corresponding, and because the lines are parallel, that means they're equal in measure also. The measure of angle 1 equals measure of angle 3. This is one of the long ones we wrote today, but we have that nice abbreviation. Parallel lines implies corresponding angles are equal in measure. So now we know that 2 is equal to 3 and 1 is equal to 3. So if they're both equal to 3, what do we know? They're all equal. So what are we doing here if we take that measure of angle 2 and put it in there?
Substitution.
Substitution. So the measure of angle 1 is equal to the measure of angle 2. What steps are we using in our substitution?
2 and 3.
2 and 3. At the bottom of your next page, you have a proof that looks like this. You're given that the two lines are parallel, and you're asked to prove that the measure of angle 3 is equal to the measure of angle 4. I want you to work on that with your group, and then we'll come back together and see what steps you all did. Okay, so let's just talk through. I'm not gonna write the whole thing out, but I want to talk through what you guys did. Shalini, what was your first step?
N is parallel to N and transversal to N.
Perfect. So first you just stated that you knew the lines were parallel. That's important in order for our other lines to be equal in measure. We need the lines to be parallel. Angie, what was your next step?
The measure of angle 3 is equal to the measure of angle 3.
Okay, so you said this one is equal to this one because they're vertical angles by the vertical angle theorem. And then Macy, what was your next step?
After that, I said the measure of angle 2 is equal to the measure of angle 4 because parallel lines imply that corresponding angles have equal measure.
Perfect. And if 2 is equal to 3 and 2 is also equal to 4, Margaret, what do we know?
3 is equal to 4.
3 is equal to 4 by what?
Substitution.
By substitution.
Steps
That
2 and
gets us
3.
all the way there. Now, could we have used angle 1 to tie them together
Yeah.
instead? And the steps would have been very much the same. 1 and 4 are vertical, and 1 and 3 are corresponding. So it doesn't necessarily matter which ones you choose, but some are going to be easier than others. So keep that in mind. All right.